Welcome, everyone. So good to see you. Some familiar faces already joining us as regular. So, welcome and good afternoon, good morning, or even good evening to some of those, depending from where you may be joining us. This is our fourth session, if I'm not wrong, Tyler, for the Marine API Office Hours and Tech Talk. So, let's get started with what we have for you today. We're gonna go over these for this talk. This Tyler is gonna be walking us through for the JavaScript policies from basic to advanced, and then we'll go over just like the regular format with the Q&A and forum discussion, so that we can go over some of the topics or dive into the some questions you may have on the topic that Tyler will present to us, and then from there we'll wrap up. So, quick reminder to those of you who may be new joining us in this session. This community was originated in Madrid by Luis Cuellar, which was having here with us. Please say hi to our audience, Luis. Um, and this community was organized for developers so that you could be more proficient and keep on learning about these two wonderful technologies we have at Google Cloud, which are Apigee and application integration. And the ultimate goal for us to organize these events, have the community spaces for you, is to empower you and have knowledge sharing, accelerate the adoption, and so that you can feel a strong sense of belonging in this community across the world. And so for this session of today, some of you already know the rules. We'll have these from depending on the time, depending on the presentations that we have for you, we'll have either two or just one presentation, which is gonna take 30 minutes of the session. And then from there, we're gonna jump into the Q&A and the office hours so that we can have discussions. Feel free to open your mic during this time so that we can get more engaged in discussions. As you know, we'll meet almost every Thursday at this time, except on the holidays and on other sections. So keep an eye on the Apigee and application integration community spaces within the Google Cloud community. All of these sessions will be recorded, so no worries in case you'll have to drop off. If anything, we'll share this via email and through the Google Cloud community, so you'll find these assets available to you. And lastly, we're still looking for volunteers who would like to join us in this forum so that you can also be the ones presenting cool stuff for the community. And with that being said, let's go over and start this session. Remember that you have the Q&A option. Just look for these three icons shared in your Google Meet and then start dropping your questions over there, or just feel free to leave them at the chat. For today, you have Tyler with you. Tyler is a customer engineer for Apigee and application integration. He is originally from the US, but he's now living in Europe, specifically in Berlin. And as of me, some of you may already know me from the interactions in the forum. I'm the developer relations for Apigee and application integration. So it's a pleasure to have you all here. And thank you, Tyler, for joining us. I'll hand it over to you.
Great. Thank you so much, Alex. Hi, everyone. Let's dive right in. Let me share my screen. I think so I have some really cool content to share with you today. So we're going to be covering extensibility in Apigee and app integration in all the different ways that we can do that. And
Tyler got frozen, right?
Yes, I think so.
Okay. I was thinking
Sorry
it was
about
me.
that, team. No. While we are here, we would like to take this time as an announcement to remind you that we'll have upcoming sessions for these office hours. So I'm gonna drop in the chat the RSVP, which is our landing page in which you can find upcoming sessions, register to all of this. So we look forward to have you in our next sessions. There we go. I think we got Tyler back.
Yes, we got Tyler back.
Nice. And I think you are muted.
yes, thank you. Sorry, we're back up again. Let me share my screen again. And we can dive right in. So here we go. Okay, great. So hopefully my screen is loading. And yes, today the topic that we have is JavaScript. So we kind of got this into a topic for this month, for January, called Apigee JavaScript January. We want to give some love, give some time to extensibility in Apigee and app integration. It's something that if you work in this field or with these products, you see that the extensibility topic is very important, right? Because not everything is built in that you need to run an API program or design super advanced integration scenarios, right? So having an extensibility concept, an extensibility model that is both powerful, flexible, fast, and efficient is really important, right? And actually, JavaScript meets a lot of these or all of these requirements. And I'm going to go through all the options today, from basic to advanced, on ways to leverage JavaScript within Apigee and app integration, the pros and cons of all of those, and give you some real examples, some demos, right, to show how you can do this at scale, how you can include testability, other advanced features into how you leverage JavaScript to extend Apigee and app integration. And as mentioned, this is kind of a theme this month, is coding, winter of code for Apigee. The next few weeks will also be coding topics, and we'll publish those very soon on the community site. And so I hope you're as excited as we are about diving into some cool coding topics in the next few weeks. To start off with, we're going to go through why JavaScript, what are the advantages of using it for customization, what are the different options. So I call this the decision tree to go through from basic to advanced. Very cool is, what's the performance impact? What are the implications? Which is faster? What are the pros and cons of these different models? And then do a conclusion and a discussion on using JavaScript and how to best leverage it. So let's get into the introduction. Why JavaScript? So JavaScript's been around for, it feels like forever, right? It's one of the oldest scripting languages in our industry. It has a huge developer reach, right? So most developers start with JavaScript in one form or another, either client side, server side, and it really runs on every platform, right? From Raspberry Pis to Chromebooks to everything else. It is very mature and stable, especially how we leverage that in Apigee and app integration, right? So, it's very important that we manage how we use dependencies. I think if JavaScript gets a reputation sometimes for, maybe also being not as stable, that comes from the whole dependency topic with Node.js and NPM and managing dependencies that can break build chains. If you've ever had a JavaScript project that you go back to it in a few years and it doesn't run because something's changed in Node.js or dependency has changed, those are all things that happen all the time. So that's why I think the topic of dependencies is really key in this area, and we'll get into that in more detail in the different options. It has really the greatest ecosystem, I would say. I mean, maybe not the greatest, but really up there. If you ask Gemini Code Assist or any LLM for coding, to generate some JavaScript to do something, if you do Google searches or Stack Overflow searches to accomplish any task, you will get, tons of great results. So you basically can really do anything very easily with JavaScript. At the moment, if you count JavaScript and TypeScript, these are the most used languages if you put them together. So Python is #1 at the moment, or at least last year. But if you add up JavaScript and TypeScript, you have the most popular. It's even more popular than Python. It runs everywhere, and it's also ubiquitous and very stable, right? So if you take care of dependency management, then this is something that you can run rock solid in any environment, right? But the dependency topic is really important, and we'll get to that in a moment. Also very interesting here is Go is way up there now. This has been something that has been also very interesting to see how Go has become also one of the key extensibility and developer platforms out there. But today we're going to focus really on JavaScript. So the options for leveraging JavaScript extensions in Apigee and application integration, to start off with, are the JavaScript policies, right? So if you do any getting started tutorials or gets up and running in Apigee, you'll quickly find examples of using the JavaScript policy. Behind the scenes, it's running the Mozilla Rhino engine, which actually compiles the JavaScript in advance into Java bytecode. It's my understanding. So it runs very, very efficient. So we're not running JavaScript at runtime directly in a JavaScript environment, but rather running compiled code, which is an advantage. The second option is using an external callout. So this is a relatively new policy in Apigee to call a gRPC service from within our Apigee pipeline. You can really easily run this on Google Cloud Run or in GKE. gRPC is pretty low latency, and so of course we can host any JavaScript there, including full Node.js environments and PM dependencies and all the rest. Right? The third option is service callout. This is similar to external callout, but is any HTTP service, right? So you have to have an API in front of it. The advantage of external callout is that that's all built in. So you just have a gRPC endpoint, and that syncs the request, response, headers, all the variables automatically. With a service callout, you need to have an API, or you're pushing basically calling an API, so you have to do the mapping yourself, right? So basically you have to do mapping to some request and get the data out of a response as well. So these two here, the external callout and service callout, are similar. You can run those in any containerized environment very easily in Cloud Run or GKE. And JS policy is really in process, in memory within Apigee proxies and application integration runtimes, and so has an advantage just that you don't need an external service running to use it. Good. So let's get into the decision tree when we're making deciding for the best option here. So if you're thinking about, okay, we need some external logic, or we need some additional logic, right, within our Apigee API pipeline, as well as in our application integration flow, the first question that I always ask is, is the algorithm that I need, is it self-contained without dependencies, right? So do I want to use external libraries? The dependencies topic is one that, a lot of people see that as an advantage to say, hey, I can use this huge library of Node.js modules. But I also think you see people more and more advertising zero dependencies as an advantage, right? So if you look at libraries out there, often they will put this as one of their advantages, right? Is there no dependencies, zero dependencies? Because I think we've all made that experience that dependencies are a double-edged sword, and they can also break everything. Also, they can bring in security risks as well, right? Because you never know, who's actually maintaining that library these days, and who knows, maybe a bad actor has also taken, over. This has happened, right, in several Node.js libraries. So the dependencies topic is really important. I think, so myself, I've become more skeptical of libraries that have lots of dependencies. I prefer always libraries, if I'm using them, with zero or a low number of dependencies, just as a sign of stability and maturity, and that this is more reliable than libraries with lots of dependencies. If we have a library where we need dependencies, then I would immediately go to a containerized environment with external callout. This means that we're in a containerized environment. We can package everything we need in the container. Then there's no issues, right? We can have the container with all the right prerequisites. All the libraries can be installed. It can be tested. Then it's for sure a great option to put that into Cloud Run and call it with external callout. If we have an algorithm that is possible to use, either we write it ourselves or we have it from some other source without any dependencies, then the question is that algorithm idempotent, meaning does it always return the same result? Is this dependent? And also you can kind of see this as, is this business logic, or is it a pure calculation algorithm that's doing some conversions or something that's contained, right? So doesn't need data from external systems, but rather it's always doing the same things, the same inputs, always the same outputs. If that is the case, then we have a very stable algorithm, right? That makes total sense to put that in JS policy. Then it can run natively directly in our runtime, and that's going to be fast and efficient and a great solution, right? If that is not idempotent, meaning that we're dependent on external data, we might get different results, right? Depending on configuration or other systems or whatever, or time of day, or whatever factors, then this is a more complex business logic. So that's what I would really call business logic, and that I think is best usually in a containerized environment and using external callout, right? So that's kind of the distinction to go through, meaning zero dependency, idempotent code, algorithms, putting them in JS policy. I used to think that the size or the number of lines or how much code is it makes a difference. I no longer think that's really so important, honestly, right? So as long as these, questions are answered, that we're not pulling in dependencies, and we always, have a contained algorithm, it doesn't matter actually if it's, a lot of code or a little bit of code, because it's always doing the same thing. We can harden it, we can test it, we can, basically embed it very nicely within, either Apigee or application integration. Same for the containerized external callout version. If it's a little bit of code, a lot of code, doesn't matter. It's more about what is it? Is it business logic, or is it a self-contained algorithm? Just a definition of idempotence. This, I guess, comes from mathematics, and literally comes from Latin, I think, meaning stable and power. So always the same, and that's where the power resides. And I think this is great in algorithms in general, right? Also for mathematics, but also for algorithms, right? So if these are reproducible, contained units, right, then it's so super portable, right? Then we can put that anywhere, including in Apigee proxies and in application integration flows, directly embedded, super fast, super efficient. Which takes us now to the performance topic. So let's take a look. So I was testing this kind of just to get a feeling of, what's faster, what's the overhead for these options, right? If we put code in JS policy, we put it in external callout. And it really is a big difference, right? Because JS policy is natively compiled. It's running in local process space, local memory. So it's also just super, super fast, right? Around single digit latency, 2 milliseconds, often less, 1 millisecond, right? So you can execute that code really efficiently in your Apigee or application integration pipeline, which is awesome. And I think for some use cases, perfect, right? As long as there's no dependencies, or very manageable and self-contained, then that's a great solution. External callout has latency overhead. We're calling out over the network to another service. Also, when it's using gRPC, it's binary. It's HTTP2. More efficient than REST potentially, but nevertheless, it's network communication, and so there's that overhead. So basically, for the same logic, it's a big difference. However, if we need a full Node.js environment, if we need libraries and dependencies, then there's no other option, and it's also not the end of the world. Depends on the API, of course, right? But now we're talking not single digit, but double digit milliseconds, and so that's just something, of course, to keep in mind to be considered. I think it's super great that we have the options, right? So, we have the low latency, embedded option. We have the external callout option. Both of them have the same capabilities. You have access to the same data, right? So all of the variables, request, response, headers, all of the flow variables, right? Everything's being passed through natively. You also get an external callout, including custom variables, custom data you can put there as well. And you don't have to do any mapping, which is great, right? So typically, if you use service callout and you call an API, you have to do a lot of mapping. External callout takes care of that for you. So it's really the same experience in both cases. So I think it's a great option. We can put anything there. It doesn't have to be JavaScript as well, right? So containerized environment, this can be Go, any environment, Java, any environment that can handle gRPC can run an external callout. We also have, by the way, as an alternative to JavaScript here, embedded native, also Java, of course, right? So for Java teams, Java developers, that surely is a good option as well. But today we're looking at JavaScript just to do the apples to apples comparison. But I think with Java is similar performance, even though I haven't done a direct test myself. But in the end, both are running Java bytecode in the end. So I think we would get similar performance with Java. Regarding the performance of service callout. So if you remember, we had the other option, service callout, which is an HTTP connection. So not gRPC, or could be gRPC, but it could also just be REST. It's similar latency. So I expected service callout to be a higher latency. It's really in the same area, at least for my tests, at least using Node.js, right? It could be this would be interesting to test as well if there's differences between Go, Java, and Node.js for the external callout with gRPC. Could be that the Go gRPC performance is just better than JavaScript. Could be. That'd be interesting to test out. I think I'll do that for sure. And so, but at least for JavaScript, we're talking just Node.js. It's similar latency, at least in my test, between external callout and service callout. So we're not getting a lot of advantages from the gRPC from the performance perspective. Good. So with that, let's jump into a demo and take a look at how exactly this can work. So you should see my entire screen. The first thing I want to show is, well, basically two source code repositories that I wanted to share today. So let's open those both up. The first one is a repository of JavaScript modules. And this is how I develop the algorithms that I use in JavaScript policies in Apigee. So I collect these in a repository called Apigee.js modules sample. And basically, anytime I need an algorithm to do a conversion, right? So this is both zero dependency and idempotent. For example, doing conversions between BigQuery API structures or Firestore API structures or Gemini API structures. This is stuff that, it's a lot of looping, it's recursion, just typical conversion. So it's very nice to put this here in this repository where I also can have unit tests of that code and then included in the Apigee proxy already tested, right? So it's hardened, it's tested, it's linted. I don't need to, have that in the console. I can maintain that as its own repository. If we take a look at exactly how that looks, basically I just have my modules that do the conversions, and then I have a lot of test data to test the conversions, right? So I don't need to make API calls to test it. For example, a little while ago, we were working with Fire healthcare data in BigQuery, and the sample data was very high, lots of levels, right? Where you're getting the API results with lots of Fs, Vs, values, and then any V could go down deeper into more and more, right? So it's basically kind of a recursive structure here, which is not fun to parse, not fun to work with. So the BigQuery functions here can handle that as well as any other BigQuery structure that's returned. And turn that into a normal resource, a JSON structure, right, that you would get from an API, right? So basically, we can run those tests. So the BigQuery test, for example, loads all of those sample payloads, runs the tests. We can develop it all locally, test it, publish it, and then use it in Apigee, in addition, or in application integration, right? One of the ways that I work with this is to, at the end of the modules, always have just an example, an if statement that tests if we can export modules here, or export methods into a module. And this works in Node.js, but doesn't work in the Apigee environment, right? So that means if we're running in Node.js, we export this method to be used. So in our test, for example, but in the Apigee environment, we don't, because this would throw an exception, right? Because this doesn't exist. We're not running in Node.js in Apigee, right? We can just run generic, straight JavaScript, core code, right? So the nice thing here is that this code then can run in both environments, so Node.js as well as Apigee, and we can test it here, develop it here, and then include it exactly as is within Apigee and app integration, and utilize tested modules that do the algorithms in the Apigee environment. Cool. So for example, here if we just run through the tests, Oops. You can see that it's very easy to run through the test, do all the conversions, get the results, see if we break anything. Right? So if we make any adjustments, we can test it here first. And then when we're ready to use an Apigee, just include it in a proxy. For example, so let's load Apigee proxies. And so for example, I have a BigQuery proxy that includes that same module that takes care of all the conversions, right? The BigQuery functions. And so anytime BigQuery data is flowing through here, that's being used to do the conversions between the BigQuery, complex JSON, and our RESTful responses. Good, so that's the topic of JavaScript to be tested and shared. Sometimes there is the myth or incorrect information that if you're using JavaScript in Apigee, you can't test it so easily, you can't do linting, you can't have a proper SDLC. That's not true. As you see here, we can have full SDLC, we can do tests, we can validate the code, harden the code, and include that then in our proxies. You don't have to, and you shouldn't develop this code in the console here, right? I mean, it's fine for checking up on it and seeing if it's there and what it does roughly. But for development, for anything that's semi, complex or doing something complex, I would definitely do it in, recommend doing it in VS Code, and then importing modules that you can use here. Good, so that's the first topic, getting into testing and developing JavaScript. These modules can be used in any environment, also Node.js. The second topic is looking at how we can use ext callouts, external callouts to also run JavaScript code in Node.js, right? So if we have, for example, a use case where this isn't self-contained, it has dependencies, then we can package that in a service and deploy it to Cloud Run, and then call it using the external callout policy. So here I have such a service. This service uses one library called Joke Generator, and it returns jokes to when it's called through the gRPC interface, right? So this imports the external callout protobuffer from Apigee, which you can find in GitHub. And basically, this has the process message RPC method, right? And we get a message context in, and we return it back. And that includes the message context, includes everything that we usually see in the tracing, and it can also process in the JavaScript policies, the request, the response, error, faults, and all of the information from the current flow, basically, right? So this is basically the contract that we get in the code. And so here in JavaScript, we add a service for process message, we get the call and the call back. And so basically when we run this, we can, for example, add headers, jokes, for example, and return those into our processing flow in Apigee. So this service is deployed in Cloud Run and is connected into this Apigee proxy, or actually another Apigee proxy called xjokes API. And here we have a no target proxy that in the response does the external callout, also a service callout just to test for comparison that also gets a joke from JavaScript running in Node.js. So basically we have all of our options here, right? So that we're shown in the different possibilities. We have the external callout with the gRPC interface. We have service callout to a HTTP REST interface. We have a JS callout locally here calling our joke module in our proxy. And then all of that we set in the response, right? So we have one assign message policy at the end that does the set response. And there we see our X joke, our service joke, and our JS joke all. The X joke is coming from the header where we set the random joke in our code through gRPC. Service joke is a call out response. And then the local joke is just stored in a local variable. So basically, we have all the options here in our flow. Let's go ahead and start that and debug it. We can also compare how all three options run. So debug session is loading. So we do a call to our jokes endpoint, and you see that the header from the external callout is there, xRandomJoke. So that came from our JavaScript external callout. And then we set all of that into the response, the external joke. Why do JavaScript developers hate math? They can never get their numbers right. The service joke came from a call out to the service. Why do they prefer JSON over XML? Because they love objects and hate tags. Okay. And then the JavaScript has a local joke in the script. You want to hear a JavaScript joke? I'll call back later. So here we have all the three extensibility options. Let's take a look at the trace and see how they ran. There was no target in this call. First, we called the gRPC. It had a longer latency because it had a cold start to start the Cloud Run. The service callout similar, although not as long. And JS and the JavaScript local JS policy only 1 millisecond, right? And then the set response, super fast, just took all those responses and wrote that into the response object. Let's do a couple of more calls just to not have the cold start effect. So here we have external callout. So over gRPC, 20 milliseconds, service callout 21 milliseconds, and local JavaScript 1 millisecond, right? So there we have all our options. Yeah, as mentioned in the slides, performance is for sure. Latency is higher with whenever we're doing external callouts. It'd be very interesting to test the external callout with Go. So I'm definitely going to do that, just to get a comparison. And for JavaScript, as long as we don't have dependencies and it's a idempotent algorithm, then it's for sure the fastest to run it embedded locally in the proxy. Cool. So that is the demo showing that. This code is all in GitHub as well. So if we, this is the second repository in the slides. So Apigee X callout sample, and this includes the source code for the external callout service. So it's using the joke service to return the gRPC data. And we also have a proxy here as well that does all of the calls, right? So we have all of the policies to do the external callout, JS callout, and service callout, and setting the response. So you can deploy this proxy directly in the Apigee environment, deploy the service, and test it out yourself. Great, and the instructions are here in the README. If you have any questions, just create an issue or add a question to the Apigee community site. And happy to build this out or add any, test any additional features that might be interesting. Cool, so thank you very much for your attention. I hope that was interesting. Any questions or discussion around JavaScript and extensions and extending Apigee and application integration? Anyone curious or have questions or experiences yourself with this topic, or recommendations for the community as well? By the way, this session is recorded, so people will find this in the future as well. And anyone who's looking up or checking up on this topic, Mike, this is a good opportunity to give some tips or to give some good ideas here.
Thank you, Tyler. We have a question in the Q&A, so I'll read it out loud for you.
Mm-hmm.
How often or how is the process of updating the libraries, JavaScript, Java, etc.?
Yeah, sure, absolutely. Great question. So in Apigee, of course, you have to redeploy the proxy every time you update the resource, right, that you're calling. And that's something I know that people have asked about in the past, also in the forum, that slows down development. I have to redeploy the proxy every time I test something. And that's exactly why we don't recommend developing here in the console, right? Because that's not very practical, right? Redeploying for every change, that just takes a long time to to develop, right? So I definitely recommend to look into developing the code in a similar repository like this, or in a different structure that works for you, and then importing it into Apigee. So that means you can iterate here very quickly, do everything in unit tests, right, to validate the algorithm, test all the edge cases, have it, make it really solid, make it really hardened, do linting, do checks on the code. And then when you're finished, you can reuse this very easily. So I reuse these libraries in all kinds of proxies. You can include this code very easily in CI/CD deployments into Apigee or app integration. And these are just resource files that are really easy to push in. So I definitely recommend having a separate development lifecycle, doing all the tests, developing the edge cases, collecting the data, the payloads, right? Because that helps really validate the code. And then when you have releases, push it into Apigee proxies and update them only when there's real releases to push out.
Thanks, Tyler. I don't see more questions in the Q&A or in the chat, so if anyone would like to just open their mic, you're more than welcome to do so.
Hello,
But if
everybody.
not,
Yes, I just want to have a question about the latency.
Sure.
If you use the external or service callout,
Uh-huh.
can you reduce the latency? Because I see if you use JavaScript, it just takes only 1 millisecond.
Right.
Is there a way for external services or external callout
Yeah.
to reduce the latency?
Yeah, that's a great question. So, I mean, theoretically, the gRPC should be lower latency than it is, right? So I'm suspecting that Node.js is adding an overhead here. So I'm looking forward to do some comparisons using Go and Java, for example, right? I could imagine that would reduce the latency just, because those might be better supported in gRPC. But other options I'm not aware of, right? I think that, yeah, I mean, this is a very simple service, right? So it's just receiving the process message, adding some headers, right? Doing some, generating a joke, putting it in the response, and that's it. Might check on, what exactly, doing some profiling here. I am logging to the console, the data. Okay, that takes a bit of time. That's probably, should remove that for sure. It's just for testing purposes. So yeah, get rid of that and just, profile it and see. But so I could imagine that JavaScript might not be the best gRPC client or server, right? But that's something to be determined, right? So we can sync on that in the forum with any updated results. I was also expecting a lower, or I mean, I think 28 milliseconds is okay, right, for doing an external callout. I was expecting more of a difference to the service callout, right, using an HTTP REST endpoint. So that will be interesting to dig into and find out the reasons there, because I would normally imagine that, okay, embedded JavaScript is the absolute fastest. They were in single-digit milliseconds. Service callout somewhere in between, and then service or the external callout somewhere in between, and then service callout. This usually I would expect it to be the slowest one, but that's not the case at the moment. So something to dig into to get some more data.
Also, additional to this, I'm guessing where you are deploying the service, the backend is also going to impact. For example, here that we are in Madrid region, ideally, if you have a service in the cloud, please be near to the runtime, right? So that's going to
that might be a good option as well. So here, my Cloud Run services are running in the same region.
Exactly.
So Europe West 4 for both the external and service callout. My Apigee instance is also in Europe West 4, but going through public internet, right? So that could also be something to improve as well. If I go to my instance configuration, you can see, okay, that's also running in Europe West 4, but I'm calling the public Cloud Run endpoint.
Yeah.
So I could go through PSC. That would be an interesting test as well, right? To call a private endpoint that's routing through a private connection, private service connect to the internal Cloud Run endpoint. And that could shave off some time as well. So that would be interesting. That might make some difference with gRPC, that we're not going through public internet. Yeah.
Of course, it should be reduce the latency because you're not going out and then go back.
Exactly, right. And PSC is very straightforward to configure, right? So that would be here in the environment configuration. Yeah, or where exactly is that? No, endpoint attachments, right? So this would basically be for everyone here. We could have different backend services, connected and have a local, endpoint to contact. And so that would be a super interesting test as well to see if we can, what the difference is between calling a local endpoint to get to a Cloud Run in the same region versus going through the public endpoint. Yeah.
Yes, exactly.
Cool. Any other questions on this topic?
Okay, so you mentioned that you are developing JavaScript code in IDE and then pushing the change to the I'm quite interested how you do this. Do you have any a kind of quick start or something to implement that, do you think?
Good question. Yeah. So I use a variety of tools. So sometimes, just Apigee CLI. So if we look at my IDE here with the X callout sample, I have all the code here in my main structure, right? So under source, main Apigee, API proxies, X jokes, that's where my module is as well, right? So I can easily pull in updates or update this file here. I'm not for this, and yeah, so we don't have in npm or a repository, but it's just updating the file, and then deploying this using Apigee CLI, for example, to my Apigee org and my Apigee environment, right? So this is very helpful to have everything in one place. You can also use Apigee CLI. Are you familiar with Apigee CLI? So this is the
Yes,
automation. Yeah, sure, absolutely, right. So this is the #1 automation tool for our CLI tool for Apigee and X and Apigee hybrid, right? So really every asset in Apigee you can access via Apigee CLI from the command line. So it's very easy. So for example, I was also configuring in this repository, configuring my target servers as well for my gRPC endpoint, right? So there's an API or a CLI command for that, like everything else. The very bottom, target servers, right? And then also for proxies as well. This is just a command here to update and deploy as well, right? So you can read up on all the commands here very easily, and it's nice, very nice CLI interface to do all the automation operations, right? So theoretically in our repository, if we have a new version of, joke module or any other module, you could push that or pull it down from GitHub or your repository, replace the file here, and then update the proxy, right?
Cool. I explored this idea to centralize the JavaScript files.
Yeah. For me, it was a big, for me, I wouldn't go back. So I started doing it originally just because it was getting out of control, the JavaScript, right? So having, longer BigQuery conversions or different versions directly in the proxies and maintaining the code there is just not sustainable. So yeah, this was really helpful. One topic to improve that we've had some discussions in the past about this, that it could be really useful to have the Apigee JavaScript model here as supported as well, right? So that you could actually have all of the code here and test it as well, right? So at the moment, how I do it is also for sensitive data protection, for example, anytime I have any complex JSON or need to do complex conversions, I'll put it in here. because then I can test it with my sample payloads. But I don't have the context object here, right? So I just make neutral functions that I can test and call, right, to do masking or do any of my conversions and everything. Just neutral functions. That's fine. It's good. I can test it. I can import it, use it. But of course, for example, the Apigee code to do context, setting methods or headers, I can't test that at the moment, right? So I have it here as well, just as a reference. Because it's something I reuse as well in lots of proxies, but I don't have tests for this, right? Because this context is specific to Apigee. I don't have an Apigee environment here locally. I mean, I could use the emulator, but that's a different topic, right? So so it could be useful to have just a local model of the JavaScript, of the Apigee JavaScript model with the context and all the structures. That's something we don't have at the moment, but it'd be pretty straightforward to do it. And then we could also test the Apigee specific logic as well. At the moment, the tests are just for the modules that do the actual conversions with clear inputs and clear outputs, in the idempotent model, right? Cool. Any other questions? So we had a couple of questions in the forum that kind of are in this area. So someone asked a question a few days ago around unit tests failing for JavaScript code. Very similar to what what I was showing today about having a JavaScript module and trying to run unit tests on it. I think the reason why it's failing is because there is no context object, right? So exactly what I was just mentioning, that could be a very useful thing in the future to have to create an open source context Apigee context object that we could very easily use in tests as well. So I think that's the issue here, is that there is no context, so you can't really test the Apigee specific code at the moment, right? So that's something to think about for the future. So I'll write a response to this with that information. So that was one forum question that was new. And then a second question that came in was around syncing JSM data to BigQuery, which is really interesting. So these synchronization topics are, so in this case, from Jira to BigQuery, for example. These are great use cases for application integration, right? Because it's really, structured data in through a connector, doing some conversions or mapping, and then data out into some other connector or some other, sync basically for the data, right? So this is really great use cases. I think that's something that with the new transformer feature in application integration, it's getting easier and easier to do conversions and logic and mappings directly in the flows with no JavaScript needed, perhaps, right? So that's where we want to get to. You can use, JSONnet is supported as well in application integration flows. It's also an open source language. It's maybe more similar to Python, but it's also coding, right? So I think with application integration, we want to get to the point where as much as possible as you can do without coding, even though it's always great to have the option, right? Just in case it's needed. But yeah, so that's something I would definitely try out here. And these mapping use cases are, great use cases for application integration, right? To get structured data in, structured data out, and take care of mapping and conversions within the flow. Cool. So if anyone has any questions or comments, feel free to jump in.
It can be also in other topics rather than this one, right?
I'm sorry?
I'm saying that you can also ask questions about other topics regarding Apigee.
Absolutely. Yeah. That's the intention of this forum, is that if, save your questions. If you have something, that you want to talk about throughout the week, just bring it here and we're happy to talk about anything and everything. So absolutely. Cool. Cool. So if there are no further questions for today, we definitely request your feedback for these sessions. That's something we're looking at the planning for this year and getting a good rhythm going. I think it's really valuable. I really value it to keep an ear to the community and get feedback and make the Apigee community and integration community as useful to everyone as possible, sharing best practices, sharing sample projects, sample code. It's something that for me as well is extremely valuable to find good ideas and good templates, how to do complex things in verified, tested, best practice ways. So that's what we're looking to build out. So all your input and feedback and suggestions are very much valued. Going forward, Thursdays is kind of our day. We're looking to think about getting the word out, bringing more people in. So talk to friends and colleagues who are interested and bring them as well. Maybe next time, maybe someday we'll have a meetup in Madrid in the origin of the Madden API. But in any case, let's keep in touch every week. Here are some of the latest articles in the forum just to take a look at. There was some really interesting stuff from Megan around security actions to block suspicious traffic in Apigee. So Advanced API Security is an add-on module in Apigee. You can enable it, you can test it in your eval versions as well, or use it in pay-as-you-go or in subscription. And the security actions feature is very interesting, right, to respond, right? So there's actions built in that can respond to block or to flag traffic, but you can also have custom actions, right? So this I think gives some good examples and insights into designing your own security actions in the security pipeline. Migrating from your northbound routing from MIG to PSC. Oh yeah, this is an awesome topic. MIGs, of course, are the managed instance groups. That is one way of getting traffic from the ingress load balancer into Apigee X. Of course, we can also use northbound PSC. So if a customer or if someone started with MIGs and wants to migrate to PSC, this looks like a great guide to help do that. I think I've done this as well in the past. It's definitely doable. It's just basically, changing that backend configuration, load balancer, having the PSC and everything set up, service attachments. So here's more information on that. I saw this guide as well, the Deploy Apigee Hybrid on AWS. I think this includes a complete deployment template to try it out. So that's very, very cool, very interesting topic. I know there's a couple of extra configurations needed in AWS, the networking level, to make it work. But in general, it's a pretty typical Helm deployment into an EKS environment. And so this should help give you a good quick start to deploy that yourself. And yes, and I saw this one as well, the technical guide on monetizing LLMs with Apigee. And this is super detailed around, and we talked about this, I think it was last week or the week before as well, ways of screening, of monitoring the traffic, right, for token counts, for other things you want to, count and put into analytics, into data collectors, and also theoretically attach monetization rules to. And IO gave a lot of detailed information and examples on how to do that. So really interesting article on monetizing LLMs, which is a super interesting topic in general, right? So I think this year we're going to see a lot of these types of projects as well moving forward. Different monetization schemes on tokens and ways of counting and doing chargebacks based on LLM token counts at different levels, right? And maybe counting is just the one aspect of it, right? But how do the packages work? What's the best way of positioning this with customers? So we'll see how this topic evolves. It'll be super interesting. Everyone is invited, of course, to always participate in our cloud community. There's been some really great updates on also the platform. So it's getting, even, fixing some issues that, making sure everything runs smoothly. So I think it's really, really powerful platform, really polished. So I encourage everyone to join in, ask questions in the forum, suggestions as well, and also all the updates on these forums. And upcoming community events, every Thursday, is this session, Portuguese session on January 21st, which is coming right up, Gen AI and SAP. Very interesting Spanish session. I think, Luis, this must be in your area, in your wheelhouse, January 29th, Gen AI and API Hub. Very cool. I don't speak Spanish, but I definitely want to hear more. And yes, and keep up to date on all the rest of the events on the community events section. Then thank you everyone for your time today. Hope it was interesting. Hope it gave some interesting insights. And as usual, just reach out, and looking forward to seeing you next week. Thank you. Bye-bye.
Thank you, everyone. See you soon.